Here's a ruler. If this is 1 centimeter, there is a space that can arrange about 100 million hydrogen atoms in a line. In the center of the hydrogen atom, there is a nucleus that is only 100,000ths the size of the atom. Let's imagine that there's something 1 billionth smaller than this nucleus. This was the size of the newborn universe about 13.7 billion years ago. All the materials needed to make hundreds of billions of galaxies were packed together in this space. The universe suddenly grew up to about 3 millimeters, then slowly expanded until now. We call this the Big Bang. When the Big Bang just happened, the universe was full of energy. Particles and antiparticles were born in pairs from energy. When they collided, they disappeared and returned to energy. This is called pair production and annihilation. When the size of the universe reached 3 kilometers, the balance between pair production and annihilation was broken. This is because for every 1 billion of pair production and annihilation, 1 antiparticle turned into a particle. We still don't know why this happened. Anyway, this happened, and even though 999,999,999 particles disappeared with antiparticles, the 2 particles survived. When the universe grew to 300 billion kilometers, the accumulated particles formed protons and neutrons. 380,000 years later, protons bonded with electrons to form hydrogen or combine with other protons and neutrons to form helium. In very small quantities, lithium and beryllium were also produced. Around this time, there were 75% of hydrogen and 25% of helium with a slight presence of lithium and beryllium in the vast outer space. However, it was not evenly spread, so some areas were a bit more dense than others. The more dense areas attracted more atoms due to stronger gravitational forces than the less dense areas. So, as time went on, the difference between the areas with high density and low density widened. 100 million years after the Big Bang, a peculiar phenomenon occurred when the density became sufficiently high. 4 hydrogen atoms fused to form a single helium atom, releasing a huge amount of heat and light. This is called nuclear fusion. We call this high-density space in which nuclear fusion occurs in succession a star. Stars live their lives in unstable equilibrium. Gravity keeps pulling atoms in and the energy resulting from nuclear fusion keeps pushing them out. Most of the stars have these 2 forces in balance, and things change once the star runs out of hydrogen which is used as fuel. Because the pushing force disappears, the pulling force prevails and the star's core contracts rapidly. Then, the density of the core becomes higher, so that not only hydrogen but also helium can be synthesized. Helium is used as fuel to make carbon and oxygen, and when helium is exhausted, most of the stars die. However, a few large stars have so much gravity that they have room for another nuclear fusion. They use carbon and oxygen as fuel to produce heavier elements, such as neon, magnesium, and silicon, in sequence, and make iron right before they die. When the star's core turns to iron, nuclear fusion stops, the atmosphere becomes very unstable, and the star explodes. Stars scatter countless elements throughout the universe. We call this supernova. After this explosion, the star's core contracts further, becoming a very heavy neutron star or a heavier black hole. In the nearly 9 billion years since the Big Bang, the countless stars have been born and died in this way. One day about 4.6 billion years ago, an unknown star died near where we live now. As this star died, most of the debris scattered in outer space reunited and became a new star. We meet this star every morning. It's the Sun. In addition, the rest of the star's remnants were brought together to form several planets. One of these planets was neither too far nor too close to the Sun, having a chance to conceive life. We call this planet the Earth. About 4.5 billion years ago, when the Earth was just born, it was a very different place. The sea boiled and the atmosphere was full of gases like ammonia and methane. Here, water molecules met with ammonia and methane to form several types of amino acids. Amino acids that floated in the primitive sea became more complex proteins as they continued to link with each other over the years. About 4 billion years ago, one of these proteins did a special job. It divided itself and created descendants. At that time, life was just a single cell, and it could move very limitedly. Even after it evolved into a multicellular organism about 2.1 billion years ago, the situation hasn't changed much for a while. One of the most important leaps in the history of life was the emergence of animals that move through nerves and muscles about 600 million years ago. Cnidarians such as hydra and jellyfish are of their kind. They did not only do basic life activities such as eating and digesting, but also active actions such as finding food and running away from predators. In order to do that, they had to react to a variety of variables, including changes in their position. As more information was being processed, a new organ was developed that previously didn't exist. It was the brain. Arthropods and vertebrates that appeared about 500 million years ago had eyes with a brain. The brain began to make a specific perception of the world around it by collecting information received from sensory organs such as eyes. It's the first level of consciousness that forms the base of our consciousness now. Animals with a brain and eyes were able to consciously choose the direction to move for themselves. Some of them chose to go to land. The arthropods took the lead and the vertebrates followed. Vertebrates that came to the land were classified into anapsid, synapsid and diapsid according to the number of holes behind the eyes. About 200 million years ago, when mammals evolved from synapsids, reptiles that evolved from diapsids were dominating the world. The representative reptile was the dinosaur. Our ancestors, mammals, had to be active mainly at night to avoid predator dinosaurs. This led to the development of a new consciousness. With more than 100 million years of nocturnal activity, mammals started relying heavily on smell. Visual and olfactory information are different in many ways. When we see something, we can tell what's around immediately. But when we smell something in the dark, we can't. They had to remember the smell of their friends, enemies, and prey, and figure out whose smell was whose. Smell is often associated with emotions. If the smell of an enemy is associated with an unpleasant feeling and the smell of a friend or prey with a pleasant feeling, they could act without thinking just by bringing up a specific emotion. Memory and emotion were different from the first level of consciousness, and could be classified as the second level of consciousness. When dinosaurs went extinct about 66 million years ago, the age of mammals began. Adapting to different environments, mammals evolved in various directions. Among them were the common ancestor of apes. About 15 million years ago, the orangutan was the first to split, followed by the gorilla. About 7 million years ago, humans and chimpanzees separated from the common ancestor. Many scholars think they originally lived in the forests of Africa. It was rich in food like leaves and fruits, and there was less risk of attack from predators. However, as Africa became increasingly arid, the size of the forest decreased. The apes fought over the shrinking habitat, and the weakest group was pushed to the wooded savannas. Adapting to the wooded savannas, they evolved into humans. Sahelanthropus tchadensis, about 7 million years ago, Auroran tugenensis, about 6 million years ago, and Ardipithecus cadava, about 5.5 million years ago, were all early humans who lived around wooded savannas. But as the drying process of Africa progressed, the wooded savannas began to turn into grasslands. About 4.4 million years ago, new humans who adapted to grasslands emerged. This is Australopithecus. If you look at the fossil of Australopithecus, the soles of the feet are arched. The soles of early humans were not like that. This arched structure absorbs the shock when the foot hits the ground, pushes it back and helps move it forward. Because of this, it is presumed that Australopithecus walked better on two legs than early humans. There were several species in the genus Australopithecus, such as A. anamensis, A. afarensis, and A. africanus. Ethiopicus, who appeared about 2.7 million years ago, was a human being more adapted to life in the grasslands. They developed strong teeth and jaws, so they could chew on soiled roots and tubers. But Australopithecus garhi, who appeared about 2.5 million years ago, developed smaller molars and jaws. They carried stone tools that were made with a few flakes chipped off with another stone. These stone tools are called old awen. Stone tools opened up the possibility of a legitimate meat diet for Australopithecus, who had mostly a vegetarian diet. When predators such as lions hunted animals and finished eating, they used stone tools to eat the meat attached to the bones, crushed the bones and ate the marrow contained in them. Humans inherited the legacy of stone tools and meat eating from Australopithecus garhi are distinguished by the generic name Homo. This is because the size of the brain has increased explosively from this time on. Through Homo habilis to Homo erectus, the brain capacity increased to 850 cc. Identifying trusted colleagues, stealing the meat left by the lions, and contemplating ways to eat the stolen meat with them, the human brain grew outward, enveloping the existing brain and eventually became a completely new structure. This part is called the cerebral cortex. Homo erectus, who appeared about 1.9 million years ago, used more advanced cognitive skills to develop a more sophisticated stone tool called a koulion and used fire to cook food. Chopping food smaller with stone tools and roasting it over a fire made digestion easier. As a result, not only did the size of the brain increase, but also the length of the intestine became shorter, which gave humans a slim waist. Then, mankind went beyond just walking. They transformed into grassland hunters and long-distance travelers. As a result, about 1.8 million years ago, some Homo erectus began to spread across East Africa and around the world. They gradually evolved into different subspecies in the process of adapting to the local climate and environment. Meanwhile, Homo erectus left in Africa evolved into Homo heidelbergensis about 700,000 years ago. They made spears and arrows by tying stone tools and branches with strings and threw them to hunt large animals. About 300,000 years ago, some Homo heidelbergensis migrated to Europe and evolved into Homo neanderthalensis. Homo heidelbergensis, who remained in Africa, evolved into Homo sapiens. They are our immediate ancestors. Homo sapiens had a smaller brain than Homo neanderthalensis, so the overall performance might have been a little lower, but there was another point. It's this form: while the brain of Homo neanderthalensis was long on both sides and back like humans before, the brain of Homo sapiens was more rounded and more developed in front. This is where the frontal lobe, which is responsible for advanced information processing, is located. The reptilian complex generated the first level of consciousness, and the limbic system, the mammalian brain, generated the second level of consciousness. The cerebral cortex can be called the human brain, and the frontal lobe has generated the third level of consciousness. This third level of consciousness perceives self as being in time and created a neat self-image called I by strongly identifying itself with certain memories. By recognizing me, mankind recognized you and us, and constantly simulated me, you, and our future. It became possible to plan strategies and tactics when hunting. Furthermore, humans began to believe in something that transcends us, such as God. The emergence of faith has enabled Homo sapiens to cooperate beyond the clan level. This has become our competitiveness as it is. About 120,000 years ago, after the last ice age, the temperature rose and Homo sapiens began experimenting with agriculture. About 6,000 years ago, after countless attempts and failures, mankind developed the first city where tens of thousands of people lived together. This is where our history began. Thank you all. If you liked today's video, hit the like and subscribe button. Thank you for watching.